Here's a video on our second day of Lesson 78, Arithmetic Sequences. Now for this day, what we decided to do was we decided to find specific terms of the sequence. And we use this section here, the 20 through 27 section, to use this recursive notation to find the values. So here's the idea for this section. What you're going to want to do is you're going to want to take the question number and add 11. So if I add 11, I get 31. So what I'm going to do is find the 31st term. That means, for instance, number 21, I'd be finding the 32nd term, and etc., etc. Now I'm going to use example number 20 to show you the full process. I'm going to start off with the recursive notation here. I'll rewrite it over on my loose leaf. It's right here. A sub n is equal to a sub n minus 1 minus 10. And they tell you that a sub 1 is equal to negative 5. So this is any term, and this is the term before it. So any term is equal to the term before it minus 10. And the first term is negative 5. So my first step is going to be to find the sequence. Now if I'm finding the sequence, that means I have to find the list of numbers. Well, I know what the first one is. The first one is negative 5. And now this right here, I'll write it out in plain English. This right here is any term. Technically it's the nth term, which just means any arbitrary term, is equal to the term before it minus 10. So if I take the term before it, this term, I can find the next one by subtracting 10. Negative 5 minus 10 is negative 15. Next term will be negative 25, minus 10 again is negative 35, dot, dot, dot. So that's the sequence. Now I wouldn't want to count all the way to 31 here to figure out what the 31st term is. That seems like a lot more work. So the way that I want you to do it is by creating the explicit notation now that you have the sequence. The explicit notation, they give you this template right here on the reference sheet. So you can use it from your notes. You don't have to memorize it. Now the two things I need to be able to plug in order to use this are a sub 1 and d, the common difference. Well, a sub 1 I know, that's negative 5. That's the first term of a. So I'm going to plug that in. A sub n is equal to negative 5 plus n minus 1 times d, which is the common difference. So what's the common difference between all these terms? Well, how do I get from here to here? By subtracting 10. Subtracting 10, subtracting 10. So the d value is going to be negative 10. Now that's the explicit notation. You don't have to distribute the negative 10, but you can if you want to. And now that I have created the explicit notation by plugging those two into the template, I want to plug in the n value of the term that I'm interested in and evaluate. So what term are we interested in? We want the 31st term. That means that n equals 31. So I'm going to plug that into this equation. I'm going to plug it in right here. And also right here. So when I plug that in, I get a sub 31 is equal to negative 5 plus 31 minus 1 times negative 10. I'll want to go to my calculator with that just to be safe. You can do it mentally if you're good at that. You can do it on paper by subtracting and then multiplying and then adding, but it's really up to you. I'm just going to go with the calculator. I've got negative 5 plus 31 minus 1 in parentheses times negative 10. I'm going to hit enter, and I get negative 305. So a sub 31, which is the term that they're interested in, is equal to negative 305. And like all questions, at the end I should ask myself, does this answer make sense? If I continued this pattern here, right, -5, -15, -25, -35, etc., does it make sense that the 31st term would be a large negative number? Yes, it does. So I'm content with that answer, and I boxed it. That's my final answer. And that's how you do the rest in the section. Your homework was, I believe, 22 through 27. So good luck.